Hey guys, how are you doing? How is everything? And as for today, we are elaborating on part 3 of forces. As I have already explained, that forces are either contact or non-contact, and we explored the friction force and the types of friction force, which are air resistance and water resistance and friction between solids, right? So secondly, and the second type of contact forces is thrust force. Thrust force actually is very simple concept. Simply, an engine is moving the car forward. This forward force is called the thrust force. One more example is the engine of the airplane is moving the airplane forward. So the forward force of the airplane is called the thrust force as well. Right? Now, you can just ask me, so does a fish have an engine inside to move forwards? I'll tell you no, but it has a certain amount of energy, a certain type of energy that make it able to push itself forward. In this type also we can call the forward force of the fish a thrust force. Okay, so simply the thrust force is a pushing force forward. Alright, let's elaborate more on forces that act on a ferry. Okay, so downward force is the weight, right? And upward force is the upthrust, and we're going to elaborate more on the upthrust now. Now the forward force is the thrust, and the backward force is a sum of the air resistance together with the water resistance, right? Okay, so one more example is on the fish. Now this fish has a weight, right? And upthrust force. Again, in a while we're going to mention or explain more upthrust force, while the forward force is the thrust and the water resistance is the backward force. Now the upthrust force. Okay, so if you find any object floating in water, so definitely there is a certain force which is pushing this object upwards. If you try to push this object downwards, you find that there is a certain force which is opposing you in the other direction. And this force only acts upward. We call it the upthrust. This force also makes anything float in the air, for example, the helium balloon, right? So now the upthrust is an upward force. It acts only upward, and it happens only in liquids and gases, right? Or we call them fluids, okay? And it makes the object float, whether in the water or any liquid or the air or any gas, okay? And it acts opposite to the weight. And this is a very important point. A very important difference between upthrust and air resistance is that upthrust acts opposite to the weight and acts only upward to make the object floats, while the air resistance acts in any direction and it acts only opposite to the movements. Okay, this is very important difference between these two forces, right? Okay, and um, I just need to mention that if an object is having a certain weight in the air, which is for example 20 Newton, right? And you put this object in water, you're going to find that its weight actually decreases. Why? Because the up because water has a certain force which is upward force, and this force is pushing the object upward, so it decreases the weight, as if it's lifting the object together with you or with the scale, right? Again, one more time. The object in the air weighs 20 Newton because nothing is lifting this object up, right? While if you put this object inside water, you're going to find that its weight actually decreases. This means that there is an upward force which is helping to lift the water up, helping to lift the object upward. Okay, and this is actually the amount of the upthrust force, and this is the evidence of the upthrust force. Alright, for now, this is the fourth type and the last type of contact forces, which is the tension force. Okay, and it's simple. Tension force mainly acts in or happens in the elastic or stretchable materials like spring or elastic band or ropes. Okay, and it acts opposite to your movement. Okay, again, if you try to stretch an elastic band, okay, you find that the elastic band particles are trying to pull themselves together in the opposite direction of your pulling, as it's shown here in the diagram. Okay, so these two persons are pulling the rope, okay, and the tension now is acting in the opposite direction to bring the particles again to their places. So tension acts opposite to the pulling force, right? Okay, so now we are done with all of the contact forces. Let's elaborate on non-contact forces, and these forces can happen from a distance. They do not actually need the objects to come in contact with each other. Okay, and there are four types: gravitational force, magnetic, electrostatic, and weight. Now, regarding the gravity, as you all know that gravity is the force that pulls the objects and people downwards, and its center is and it is coming from the center of the earth, right? Okay, and definitely the gravity is the force that gives us the weight. As you know that weight is equal to the mass multiplied the gravity. So without the gravity, actually your mass will be exactly your weight. Okay, so for now, let's imagine that there is no gravity. Okay, what will happen? Or sorry, this is a gravitational motion. So in this animation, we're showing that this is the effect of the gravity, that the Earth keeps rotating around the Sun in a fixed orbit. Now let's make the gravity off. What will happen? Okay, so no way that the Earth is going to keep itself in the same track, and it's going to leave its track away from the Sun. Alright, so to conclude that the gravity makes the object rotate around the Sun in a fixed orbit. Okay, now we have a very important law to study, which is the law of universal gravitation. And it's mentioning that, or states that, the gravity depends on the mass and also on the distance. Now, it's saying that all the objects and the people are having gravity between each other. Okay, so for example, you and your desk, you are having a certain amount of gravity between each other, and the books on the desk are having gravity between them and yourself as well. So all of the objects and people have gravitational force between each other, and this gravitational force depend on the mass and on the distance. Now, the higher the mass, the higher the gravitational force. You're going to ask me, why are we not having the feeling that we are having a force of gravity between each other? Actually, because our masses are very small. But when it comes to bigger masses and huge masses like the planets, we can experience and we can feel the gravity, because the masses of the planet is really huge, while the masses of ourselves and the objects on the earth is really very small, so we cannot feel the gravitational force. So again, gravity depends on the mass means that the higher the mass, the higher the gravitational force. One more factor that makes the gravitational force different is that The higher the distance, the lower the gravitational force. The more or the further the objects from each other, this means that the gravitational force between them is going to be less, right? Okay, so again, the higher or the bigger the size, the more the gravitational force. And the higher the distance, the less the gravitational force. Okay, let's increase the mass here. Can you see that while we increase the mass, the gravitational strength is increasing? And now let's increase the distance. As you can see that while we increase the distance, the gravitational strength is actually going down, right? Okay, now regarding weights. So weight is equal to the mass multiplied the gravity, okay? So weight is a kind of force, okay? And this is your weight, which is the act of the gravity on your mass. And this force is measured in newtons, okay? So now you spot out the difference between weight and the gravity. Gravity is only a force, but weight is the action of this force of gravity on a certain mass, right? And we have already elaborated on this in measurements that masses are always constant while weight is changing because weight depends on the gravity of the planet you are on, right? Okay, again, one more time. Mass is the amount of matter in an object while weight is a force due to the pull of gravity. The unit of measuring the mass is kilograms or maybe grams, and the weight is measured in newtons. Mass doesn't ever change, okay, while your weight is actually changing because it depends on the gravity of you or of the planet you are on. Well, you can take this quiz, okay, in order to make sure that you have got all the points. Now, the third type of the non-contact force is magnetism. And to explore more, to make it clear for you, just need to imagine that if you have some paper clips away from a magnet from a certain distance, you're going to find that the magnet is actually attracting these paper clips. They doesn't need to become in contact, while the magnet can attract the paper clips from a certain distance, even if this distance is small, but actually they do not really need to come in contact with each other. Okay, and the fourth type of the non-contact forces is the electrostatic force. This is the force between charged objects. And as we have made this experiment in the classroom, if you rubbed any plastic, maybe synthetic object, you're going to find that it becomes charged. Okay, these charges are actually present inside the substance, but when you rub it, these charges are coming on the surface, and actually the positive charges are attracting the negative, while the positive and positive repel and the negative and negative repel each other. So the like charges repel each other while the opposite charge attract each other, and this is a type of force. Alright, so we can take this quiz once again. We have already done this quiz in the classroom, but you can take it in order to make sure that you got all of the points clearly. Alright, so thank you very much for being with me. Don't forget to review balanced and unbalanced forces, and best of luck. Bye bye.